Okay. Lexi's here. All right. Okay, can anybody hear me?
Yes.
Okay, thank you. All right, well, wait a minute. People are just logging on. You can, if you're here, you can log your name into the chat so that I have a record of you being here. So that's something you could do right away while we're waiting for other people to show up. Okay. Thank you. All right. Okay. It's still early, so I'll stall a minute. I have a couple things to do. I want to kind of go over forum and essay answers. I have to grade last week's forum yet, but I've otherwise graded most of the forums. I have most of the labs graded, but I haven't entered those yet, but I will. So those things are there. If you haven't been keeping up with forums and lab assignments, catch up, okay? But it's something you should be doing. It doesn't take that much time. The forums, there's maybe 10 minutes of stuff to look at before you can write. And so catch up with those. There are some people who haven't done all the forums, and so we should make sure to do those. Okay. All right, let me share a screen on forums and essay questions, and we'll look at that. Okay, the first one is on essay questions for the exam. So it's harder for me to write a lot about a lot of comments on your essays because I can't write on it. So I wanted to talk a little bit about you know, answers that aren't so good and better answers and how to approach it. So I have a sample question here and then a couple sample answers. And so in science, we're looking for you to support statements that, you know, when you say something, it's not just good to be right, but what is the evidence? What are the examples? And so specific examples and specific details to support your answer are crucial, and making sure you get those things right. So I have a question here. Why is water important in the human body? Could you replace water with another chemical? Okay, and I have two answers there. Let's see if I can make them a little bigger. Maybe that's too big. Okay, well, I guess that's big enough. Okay, so one answer here, I'll read it. Without water, your body will not live for more than a few days. Your body is made up 90% of water. Water flushes out toxins, helps you sweat, keeps your skin moist, and improves circulation. No, you cannot replace water with another chemical. You need it to survive. Okay, let's read the second answer and then I'll comment. The second answer. Water is extremely important to our body. It makes up about 60% of our body. First off, body fluids like water, CSF, cerebral spinal fluid, sweat, digestive fluids, and intracellular fluids are mostly water. Water cushions and supports our joints. Water also helps eliminate waste through urinating. Water is crucial to regulating our body temperature. Many substances dissolve in water and are transported in water. Water participates in chemical reactions. What makes water so useful is the elements it's made of, hydrogen and oxygen. They form polar bonds, thus water forms hydrogen bonds with DNA, proteins, and ionic compounds. I don't think you could replace water with another chemical. Okay, so both answers are similar in some respects. They both talk about the body, although the second answer has a lot more details. and the details are correct in that it's 60% of our body is water, not 90%. 90% of blood is water. Then when they talks about the function of water, the two questions word things in different ways and have different amounts of detail. Water flushes out toxins is in the first answer, and the second answer, water also helps eliminate waste through urinating. Okay, flushes out toxins is a common term you hear, a common expression you hear, but it's not correct in that it's not like flushing like a toilet. Um, Substances are dissolved in water and eliminated through the urine. There's no flushing. There's filtration, there's secretion, but no flushing. Flushing is kind of incorrect. Um, Water is involved in temperature regulation, and that temperature regulation includes the flow of blood and sweating. The first one talks about sweat. The second is talking about temperature regulation. Water, keeping your skin moist and improve circulation. Again, these are general expressions that are not quite anatomically or physiologically correct. It's better to say many substances dissolve in water, and water participates in chemical reactions. And then the first answer just has a statement: no, you cannot replace water. Okay, and that's just unsupported by evidence or example. And the second one says water is useful because it has hydrogen and oxygen. They form polar bonds, and then water can form hydrogen bonds with other substances. Much more detail, answer that's much better supported. So they're similar in kind of what they say, although the second answer has much more detail, and it doesn't rely on expressions that are incorrect or commonly used, but not really coming from anatomy and physiology. And so that's kind of key. And then I have the forum question. There was a forum question about cancer. It said, how do you feel about cancer? Do you feel you understand the causes of cancer and will be able to avoid getting cancer? Or do you feel it's more like getting struck by lightning and you might as well enjoy yourself? Okay, and so I have two answers here. Let's read those. The first one, cancer is everywhere. You can try to avoid cancer by avoiding things like cigarettes and alcohol. However, cancer is genetic, so you may get cancer regardless. Mostly, I would say it's unavoidable. I've known lots of people who got cancer. I'd say it's best to enjoy yourself while you can because you never know when an illness like cancer can get you. It's genes and chance. Okay, so that's the first answer. The second answer is I have definitely been affected by cancer. My father had skin cancer and prostate cancer. He survived both, but the prostate cancer treatment took years and was really hard. I don't think we know how to prevent all cancers, but I know what causes some cancers. Skin cancer is caused by ultraviolet light. Carcinogens in cigarette smoke cause lung cancer, and carcinogens in some food cause colon cancer. The damage to DNA causes cancer if it hits the wrong genes. I've never smoked, I use sunscreen, and I rarely eat processed food. I believe I am cautious, but not overly scared of getting cancer. Okay, so again, it's the level of detail, and it's details that have been presented in the forum prompts and in the textbook. Okay, it's damage to DNA, so that's mentioned in there, and it's mentioned what causes damage. Cancer involves genes, but to say cancer is genetic implies that it's hereditary. It's not hereditary, it's caused by the environment, by things in the environment that damage DNA. Okay, there's lots of things that damage DNA. Some people are more susceptible to that damage. That might be hereditary, but actually causing cancer is not hereditary. So again, it's the level of detail. The first answer really uses no material from the prompts. Okay, it relies on experience, which is fine, and feelings is fine, but there's no evidence that the person watched the prompts or read the book. The second question has stuff that clearly comes from the prompts, clearly comes from the textbook. Okay, anybody have any questions? Okay. Most people are doing nice jobs on the essay questions, although sometimes people drift off. And you want to look, you want to use the textbook, you want to use the prompts on the forums, look at that stuff. It should impact your answer. It should show up in your answer. And so it's not just about, it's asking you about how you feel, but you can answer that more than one way. But it's the kind of support you give for the answer that's really helpful. Okay. All right. Let's see. Okay, that took longer than I want. All right. Again, type your name into the chat so that I know you're here. Let's try another share. We'll go over some more skeletal system stuff. Okay, so let's go to that. Does anybody see the baby with the skeleton one piece? The skeleton one piece. Anybody? Yes? Or? Okay. Can someone, like, if you see the baby, can you give me a thumbs up or say yes?
Yeah, I see it.
Okay. So I'm gonna, okay, thank you. Okay, so I'm gonna just go over the appendicular skeleton with some images. Okay, and so let's try that and see how that goes. Okay, so we're just gonna describe the bones and their important landmarks with some nice images. So first I'm gonna go over the upper limb and the pectoral girdle. Okay, the scapula. The common name for the scapula is the shoulder blade. It's kind of a triangular piece bone that at one of the corners has a flat surface for the head of the upper arm bone. That flat, smooth surface is the glenoid cavity, a really important landmark. You should know that. On the back surface of the scapula, you can feel it if you reach around behind your shoulder, is the spine of the scapula, an important point for muscle attachment that continues all the way out to the tip of the shoulder where it's going to meet up with your collarbone. Okay, and so this acromion is another important landmark that projects off the spine of the scapula. Okay, so that's the first bone. The second bone is the collarbone. It goes from your sternum right here to the tip of your shoulder. And so it's the attachment that holds the scapula in place. The scapula is pretty mobile. The only thing that really holds it firmly attached is the clavicle. S-shaped bone, very weak joint, moves a little, easily damaged. That's a separated shoulder. Okay, you don't have to know any of the landmarks here. Okay, the upper arm bone, okay, your upper arm. Okay, this is going to hit the scapula, the glenoid cavity of the scapula at the head. You need to know the head. What else? You need to know there's a big ridge next to the head, the greater tubercle. That's for muscle attachment. Then below that is another projection, the deltoid tuberosity, again, for a large muscle, the deltoid. Then on the distal end, on the back, when you straighten your elbow out, you know, you've got this sharp point, but it appears to disappear when you straighten your arm out, and that's because it goes in the olecranon fossa. So that's the little hole that holds the elbow. And then you've got two articulations with the bones of the lower arm. The capitulum is for the radius and the trochlea is for the ulna. Okay. So then when we go to the lower arm, you got the radius and the ulna. Okay. The ulna has the trochlea notch, which articulates with the trochlea of the humerus. It also has on the edge of that is the olecranon process, which is the part of the elbow you use to get what you want when your brother or sister is getting close to it. Then There's a little coronoid process and a radial notch. The radial notch articulates with the radius so it can rotate around the ulna, and the coronoid process separates it. And then at the distal end, there's a styloid process for holding the wrist in. The radius has the round head. On top, it articulates with the capitulum of the humerus, and on the side with the radial notch of the ulna. The radial tuberosity is a bump just below the head. That's for the biceps muscle. And then there's also a styloid process on the radius, and that's for, again, holding the wrist in. Okay, and so here we look at the end of the radius and ulna, the two styloid processes, and then you see the carpal bones. There's 8 of them in 2 rows. They make up the wrist, so you can take your hand and you can do this, or you can do this. So 2 different types of waving. Then from the carpal bones, you have the metacarpals. They make up the body of the hand. Okay, they're numbered 1 through 5 from the thumb. And then you have the phalanges, the finger bones. Okay, 3 in each finger, 2 in the thumb. Okay, so then you can see some of these landmarks right from the surface. You can see the acromion, you can see the borders of the scapula if someone has their shirt off. If they have bare arms, you can see the olecranon process right there. You can see the ulna and the radius. Ulna's there, radius is there, and then you can see some of these other bones. Okay, so let's skip this, and then we'll just go to the pelvic girdle and the lower limb. So a similar kind of set of things. The pelvic girdle consists of 2 coxal bones. They are joined together by the symphysis pubis anteriorly, and then they join the sacrum. It's part of the vertebral column. Okay, there's lots for us to know on the coxal bone. It's made up of 3 bones from the embryo: the ilium, which is the big wing part, the pubis, the anterior part, and the ischium, which is the posterior part. If you look at it from the side, you can see the acetabulum, where the head of the thigh bone goes. You can see the iliac crest, that's the top of the ilium. You can also see a hole kind of between the pubis and the ischium. That's the obturator foramen. And then the ischial spine projects from the ischium. Okay, you can see some of these things, like the iliac crest, you can see right from the surface, right there. You can also see, when you look at pelvises, you can see the difference between male and female pelvises. Female pelvises have to be broader and flatter with a bigger pelvic outlet, so that the birth canal will pass through that. So a baby has to be able to pass through that. So they have a fairly flat subpubic angle. The hips are kind of splayed flat out, whereas with the male, they're tall and thin, and the space between the ilium and on one side and the ilium on the other is relatively small. So when we look at the differences between the pelvis, they're kind of listed here. They're in your book as well. I'll post this PowerPoint in Moodle so that you can see it. Okay, so then the upper leg bone, the thigh bone, again, you have to know the head, which is going to go in the acetabulum. Again, there's a big muscle attachment, the greater trochanter. That's for your gluteus maximus, the biggest muscle in your body that helps you stand from a sitting position. Okay, and then you have to know the lateral and medial condyle. It's on the distal end. That's what our weight is going to rest on in the knee joint. And then there's a patellar groove for the patella there. I'm not going to say too much about that because we haven't talked about the tibia yet. There's the patella. It's bone in the tendon of the quadriceps muscle and kind of protects the front of the knee. Okay. Lower leg bones are the tibia and fibula. All the weight rests on the tibia, and the tibia has medial condyles and lateral condyles. And those medial condyle and lateral condyle on the tibia carry the weight from the medial condyle and the lateral condyle of the femur. The tibia also has a crest on the front and a projection on the distal end called the medial malleolus, which will hold the ankle in place. The fibula kind of supports the tibia, and it projects a little bit beyond it too, forming a clamp around the ankle. And so that's the lateral malleolus. And you don't have to know much about the fibula other than it's lateral. The fibula is a weak bone. It doesn't carry much weight. It's most likely to break in when people turn their ankle hard, particularly if they turn their ankle hard where the foot goes, the sole of the foot is facing upward on the outside. And so this has a tendency to break off the end of the fibula. Sometimes you can break the end of the tibia, little bits of it off, but it's usually the fibula that breaks. Then you get a walking cast because you're as long as you don't rotate the ankle too much, you'll be okay. All right, so the bones of the foot, first I should say the ankle. The ankle is really 7 bones, again in rows. There are 2 of these you have to know. They're much larger than the other ones. The heel bone, or calcaneus, projects posteriorly, and so is the biggest bone and the one that projects backwards. And sitting right on top of it is the primary joint with the tibia, and that's the talus bone. So you have to know the calcaneus and the talus. Okay, they form the bulk of the motion and the majority of the back row of the tarsal, or the tarsal bones. Then projecting anteriorly from the ankle are the metatarsals. Again, there are 5 of these. They form the body of the foot. And then projecting anteriorly from those are the toe bones, which are phalanges again. We call those phalanges. And again, there's 3 in each toe, just like 3 in each finger, except the big toe, which has 2. Okay, and so again, like the thumb, there's a reduced number of digits in that one. Okay, so let's stop the share there. Does anybody have any questions? Okay, so I will post that on this week's Moodle. I will post a little thing for the axial skeleton and the skull also. So 2 more PowerPoints that you can look at the slides. They have nice pictures and they're labeled, so it's helpful. I'm going to sign off a little bit early. There is a practice exam set up in the lab that will be available until noon. Okay, I won't be there the whole time, but I may stop in once or twice to make sure things look good. You can see sample questions, a wider sample of questions. There is a key posted on the front room next to the document camera, and the rules for taking the exam are on the board and on the door. And so it's a good bit of practice if you're in the neighborhood before noon. Does anybody have any questions? Okay, before you sign out, make sure your name is there on the chat. Let's see, I think everybody's there. Okay. Yeah, there's Olivia. Okay. So no questions? All right. Okay, hopefully have a chance to stop in and look at the practice exam. Study this weekend. Learning the names of bones and then the names of landmarks, it's repetition that matters. Okay, got to go over it a bunch of times. Write it, say it, look at it. Flashcards are very helpful. Make your own, that's all helpful stuff. Okay, all right. I hope to see you. Hope you have a nice weekend, and we're gonna end the meeting right there. Thanks.